In this video, we're going to be talking about ratios and the basics of ratios. So we're going to cover four things, the first of which is what are ratios? And second, how do you write ratios? What are equivalent ratios? And how do you compare ratios? Now, a lot of this should be reviewed from sixth grade because you do talk about ratios in sixth grade, but it's a nice reminder when we start talking about our unit on ratios. So first of all, what are ratios? A ratio is a comparison of two quantities by division. So we're comparing two amounts using division. So you may find these familiar. Ways to write ratios, kind of like fractions. A fraction is a kind of a ratio, but not all ratios are fractions. So we can write them in three different ways, using the word 2, using the colon, or using fraction form. So 3 to 9, 3 to 9, and 3 to 9. And ratios can express part to part to whole, or whole to part relationships. So how do you write ratios? And like I just said, there are three ways to write a ratio. We can write a ratio using the word 2. So for example, we've got a picture over here with some red dots and blue dots, and the ratio of the red dots to the blue dots is 5 to 2, because we're just simply comparing the number of red dots to the number of blue dots, and there are 5 red dots and there are 2 blue dots. So that ratio is 5 to 2, and we can use the word 2, 5 to 2, because we're comparing the two groups to each other. We can also use a colon. The ratio of red dots to blue dots is 5 to 2, and you still say the word 2 there for the colon, 5 to 2. And then finally, we can use it in fraction form. And we got to be careful with fraction form, because usually when we see fraction forms, we assume it's a fraction, but it's not always a fraction. It's just written in fraction form. We would still read this as 5 to 2, not 5 halves. So we have to be careful and know the context that we're dealing with here when we use fraction form. But that is a pretty common way to write a ratio. So how do you write a ratio? Here we're going to compare the number of red dots to the number of blue dots, again, in different ways. And I said a ratio can make a part-to-part comparison, a part-to-whole comparison, or a whole-to-part comparison. And I'm going to show all three of those here with just our simple red dot and blue dot example. So first we can make a part-to-part comparison. So if we want to compare the ratio of red dots to blue dots again, we could say that the ratio is 5 to 2, using the word 2, 5 to 2 using the colon, or 5 to 2 using the fraction form. And then we can also compare the number of blue dots to red dots. So we're just turning it around, blue dots to red dots ratio. So when you're writing a ratio, the order you put the numbers is very important, because it describes the relationship you're talking about. So blue dots to red dots is a ratio of 2 to 5, because there are 2 blue dots for every 5 red dots. Or we can use the colon, 2 to 5, or fraction form, 2 to 5. So notice they're the same thing, but just flipped around. So the order in which you specify what ratio you're talking about, that tells you what order to put the numbers. A ratio can also make a part-to-whole comparison. Now this is a fraction. Every fraction makes a part-to-whole comparison. So the ratio of red dots to total dots would be 5 to 7, since there are a total of 7 dots in the diagram. So we're comparing the portion of the total dots that are red to all of them together, 5 to 2. So again, we can write that with the colon, 5 to 7, or sorry, 5 to 7, and in fraction form, 5/7. Here it would be appropriate to say 5/7, because 5/7 of the total dots are red. And then again, we can make the comparison of blue dots to total dots. That would be 2 to 7, and we can use the colon, 2 to 7, or 2/7 of the dots are blue. And then likewise, lastly, we can make a whole to part comparison. Again, this is like part to whole, but just turned around. So the ratio of total dots to red dots would be 7 to 5, 7 to 5 using the colon, or 7 to 5 using fraction form. And then the ratio of total dots to blue dots would be 7 to 2, 7 to 2 using the colon, and 7 to 2 using fraction form. So those are the ways that we can write a ratio, 3 different ways to write a ratio, using the word 2, using the colon, or using fraction form. So here we have a picture of students in a class. We got a bunch of boys and a bunch of girls. What is the ratio of boys to girls? Well, if we just count the number of boys up, there are 12 boys. 2 rows of 6 makes 12 boys, and there are 2 rows of 4, so that's 8 girls. So the ratio of boys to girls is 12 to 8, and the ratio of girls to boys is 8 to 12, and I'm going to write those in fraction form just to save a little space there. Now we can also write these ratios in a little bit different way. We could also say the ratio of boys to girls is 6 to 4, because for every 6 boys, here's 6 boys, there are 4 girls. Here's another group of 6 boys and another group of 4 girls. So we could say that the ratio is 6 to 4. So likewise, we could also say the ratio of girls to boys is 4 to 6. That's a simpler way to put it, or we broke it down into smaller groups. So these ratios are actually the same thing. They're describing the same relationship. Well, we could even take it a step further and say that the ratio of boys to girls is 3 to 2. For every 3 boys that we have in the class, there are 2 girls. 3 boys, 2 girls. 3 boys, 2 girls. 3 boys, 2 girls. So another way to say that is 3 to 2. So all 3 of these ratios are basically describing the same relationship between the boys and the girls in the class. And then likewise, we could say for every 2 girls, there are 3 boys. So when it comes to writing ratios, sometimes we can write them in simpler ways. And then lastly here, what fraction of the boys or what fraction of the class is boys? And there were 12 boys, and there are a total of 20 students in the class. So 12 out of the 20 are boys, which would be, in simplest form, 3/5 of the class. And then what fraction of the class is girls? That would be 8 out of the 20. And in simplest form, that would be 2/5 of the class is girls. So again, all of these ratios making comparisons between one group and another, and lots of ways to do that. So what are equivalent ratios? Equivalent ratios are ratios that describe the same relationship. They are equal. So just like we were talking with the boys and girls, there were different ways to describe that same relationship between the boys and the girls. So again, we'll go back to the red dots and blue dots example here. Every time you make a duplicate of this ratio, you are creating an equivalent ratio because the same relationship is still there. It's just duplicated over and over again. So the ratio of red dots to blue dots, we said, was 5 to 2. Now, if we take that and duplicate it, so here we've got one set and another identical set of 5 to 2. So here we've got 2 sets of ratios that are 5 to 2. Now there are 10 total red dots and 4 total blue dots. So I've created a new ratio that is equivalent to the first one because I just made a duplicate of that exact same ratio. So I've got a ratio of 5 to 2, and I duplicate it to get a ratio of 10 to 4. These two ratios describe the same relationship. For every 5 red dots, there are 2 blue dots. It's the same ratio, just got scaled up. It got duplicated. And then again, we could do it again, and I can make another duplicate of that ratio. So now I've got 3 sets of that 5 to 2 ratio. So I made a duplicate of it again, and now I've got a ratio of 15 red dots to 6 blue dots. So this ratio again describes the same relationship. Every 5 red dots, there are 2 blue dots, but I just duplicated it over and over again. And that's essentially what creates equivalent ratios, when you duplicate a basic ratio over and over again. All of these ratios are equivalent. They describe the same relationship. Every 5 red dots, there are 2 blue dots, but we just duplicated it over and over again. So when we're given a ratio, how do you create equivalent ratios? Well, just like when we create equivalent fractions, we say we can scale them up or scale them down. And sometimes we say we simplify a fraction. We're really scaling it down to a simpler version of it. So here's a couple of examples of ratios, and let's create some ratios that are equivalent to these given ratios. So we can scale them up or scale them down. So we can duplicate or divide. So if we duplicate the ratio, that means we're multiplying it. We're making it larger. So if I have a ratio of 16 to 4, I can duplicate that ratio. If I have another 16, that gives me 32, and another set of 4 is 8. So a ratio of 32 to 8 would be equivalent to 16 to 4. So that would be duplicating it by doubling it, 2 sets of it. And then if I have another set, that would be 3 sets of 16 to 4, or basically multiply by 3, I would get a ratio of 48 to 12. And that would be equivalent. Or I could go even further and do 4 sets of my 16 to 4 ratio, multiply each of those values by 4, and then I would get a ratio of 54 to 16. And then we could go on and on and on forever, creating equivalent ratios just by duplicating that 16 to 4 ratio. Likewise, we can go the other direction, and we can kind of break it down by dividing. So if I divide this into 2 equal groups, divide both of these by 2, I would get a ratio of 8 to 2. That would be an equivalent ratio. And then I could go one step further. These are both divisible by 4. I can divide them both into 4 equal groups. So that gives me a ratio of 4 to 1, and then that's going to be in simplest form. I can't divide that ratio down any further. So now here I have a whole string of equivalent ratios. All of these ratios describe the same relationship: 4 to 1, 8 to 2, 16 to 4, and so on. All of these ratios are equivalent. So when you're creating an equivalent ratio, you can scale it up or scale it down, duplicate or divide. Next one, a ratio of 3 to 5. This ratio is in simplest form, so I can't divide this down any further, but I can duplicate it. So if I have another set of 3 to 5, that would give me a ratio of 6 to 10. If I had 3 sets of this, that would be a ratio of 9 to 15. If I had 4 sets of 3 to 5, that would give me a ratio of 12 to 20, and so on and so forth. Forever I can do that. So I can multiply both numbers in this ratio by the same thing, and that essentially duplicates the ratio over and over again, creating equivalent ratios. So how do you compare ratios? How can you tell if 2 ratios are equivalent to one another? Well, we can compare ratios the same way we compare fractions. You can write the ratios in simplest form to see if they're the same, because if you can divide them down or scale them down to the exact same ratio, that means they both describe the same relationship. Or we can rewrite them as decimal values, so we can kind of treat them like we would treat a fraction and turn them into a decimal value to see if the decimal values are equivalent. That's how we compared fractions in our number systems unit. So are these ratios equivalent? So 7 to 3, is that equal to a ratio of 128 to 54? Well, we can simplify these ratios. This first one is already simplified, which is 7 to 3. And if we simplify 128 to 54, these are both divisible by 2, and that gives me 64 to 27. 27 is only divisible by 3 and 9, and neither one of those will divide 64, so that is in simplest form. So a ratio of 7 to 3 is not equal to a ratio of 64 to 27. They're both in simplest form. Likewise, we could have turned these both into decimals, top divided by bottom. 7 divided by 3 gives me 2.3 repeating, and 128 divided by 54 gives me 2.3703 repeating, and these are not the same decimal values, so they're not equal. So 2 different ways to do that. Method 1, method 2. Simplify or turn them into decimals. Next one, 12 to 15. Is that equivalent to a ratio of 16 to 20? Well, the first method would be to simplify these ratios and write them in simplest form. These are both divisible by 3, so I can rewrite 12 to 15 as a ratio of 4 to 5. And these are both divisible by 4, so I can divide them down to a ratio of 4 to 5. They simplify to the same ratio of 4 to 5, so they are equal. And then again, if I were to write these as decimals, that was method 1. Method 2 would be 12 divided by 15 is 0.8, and 16 divided by 20 is 0.8. So either method would conclude that yes, these are equivalent. And then the last one, ratio of 9 to 4 and a ratio of 25 to 5. The ratio of 9 to 4 is already in simplest form. And if we simplify this, these are both divisible by 5. This would be equivalent to a ratio of 5 to 1. They do not simplify to the same ratio. They are not equivalent. And then again, that was method 1. Method 2, 9 divided by 4 is 2.25, and 25 divided by 5 is 5. And these two decimal values are not equivalent, so both methods get us the same conclusion. No, those ratios are not equivalent. So that's the basics of ratios, how to write them, how to write equivalent ratios, and how to tell if two ratios are equivalent to each other.